Hey, let's talk material prep. Please, let's talk material prep. Is it critical? What happens? What do you do on carbon steel, stainless steel, aluminum, poop tube? Got some old rusty poop tube here. We did TIG 101 and there were some beautiful comments from our viewers. Questions were, well, what do I do here? How do I prep my material? What happens if you don't prep it? What if I prep it correctly? I'm still getting some of the weld problems. We'll go through those. So I'm going to weld on a dirty piece of carbon steel. I want to clean a piece of carbon steel up. Stainless, we can talk about that. There's really no need to get into it and really double clean the daylights out of it. We've got 2 aluminum coupons here. We'll do one without cleaning it, and another one we will prep, and we'll show you the difference of what happens in the weld. So I have standard abrasives. Got a 1/4 inch wheel, wire brush, flapper wheel for the grinder. So again, we're going to start out and do proper cleaning on carbon steel. So the first thing I've got here is a regular carbon steel coupon. It has some mill scale, looks like some pickling gray on it. Okay, so it's not clean enough for TIG welding, and that's what this is all about, prepping for TIG. So the first thing I want to do is I'm going to attempt to just hit it with a wire wheel and see what happens. So I'm going to put this up on edge and I want to get into this surface and see if I can't clean all this off and prep it for TIG welding. Is that clean enough? In a lot of instances, yes it is. If it isn't clean enough, if I can't break down through that surface where I get to clean white metal, then what I should probably do is just get a regular 1/4 inch disc out, and I want to lightly touch that so that I break this surface down and get rid of that mill scale. That was very light pressure. Yes, I did cut into it a little bit, but I wasn't gouging into it, but it did cut it off of there quickly. Another option is to just go with a flapper disc. They seem to cut fairly well. And I want to wipe this surface. As far as the surface condition, I kind of prefer the flapper as far as how clean it is. So this was just a coupon of carbon steel, coupon. Let's get into something. I'm going to repeat this process on something that this is not going to clean up very well. This is a piece of square tubing. It's showing some pock, some rust. It's pretty manky. First thing I'm going to do is hit it with a wire wheel. I'm probably just going to kind of polish the rust off there. It will not be clean enough for TIG welding, and I want to show you that. Great viewer questions about how to do stuff and how it relates, what's right and what's wrong. Again, I'm always using a wire brush up here on edge. I am not turning this down flat. Okay, so I think all I did was shine the rust. I do not think that that's clean enough because of the pock and the surface condition of it's deteriorated from rust. So the next thing we'll do is the 1/4 inch wheel. Notice how I did that, Cub? It's all in the flick of the wrist. And then the last one we'll do is the flapper disc. So a minute ago when we cleaned up the flat coupon, I said that my preferred method for speed and surface condition would probably be the flap disc. My preferred condition on this piece of tube, because of its condition of how it came to me, is going to be the 1/4 inch grinding disc. Why? Because the wire wheel just kind of sat up here, and I polished this a little bit. I knocked the rust off, but I really still think that the rust and the pock is that surface condition that's eaten away a little bit from being out in the weather. It just kind of laid up on top of it. The 1/4 inch disc, even with light pressure, cut that away, and I got down into clean steel fairly quick. When I went to the flapper disc, yeah, I could really bear down and abuse the disc. I'm kind of waiting on it, so it's taken a long time. I got into this part over here and it cleaned it to pure metal, I should say, and it's kind of sitting over here and floating on this. So again, not to spend a lot of time, just trying to use just normal use of simple abrasives, common abrasives, okay? So let's make some welds on the carbon steel samples. My machine is already set up, DCEN, 15-20 cubic feet per hour. Let's sit down here and make some welds on these carbon samples. All right, you want to try that again? Had the cub over here jacking around while I was eating lunch earlier, and he stuck a piece of aluminum in on me for my tungsten, and I think he's still hacked off because I tossed his gloves on the ground, or I beat him in that challenge he called me out. Paybacks, I'm telling you, that guy, he's something else. I'll get him back. All right, let's go. Uncleaned carbon steel. That essence of oils. It welded okay. It looked a little sluggish to me. I'm seeing a little smoke come off of it. I can definitely smell that oil that came off of it, but it's okay. We'll do one that's definitely uncleaned here in a little bit. So this was just straight from the factory. Got a little grease on it, a little gray color to it. It's definitely not clean. So let's go to the portion where we hit it with the high-speed wire wheel on edge. Let's see what happens with that. Oh, that was even stranger yet. The weld pool seems like it's wandering all over the place. My assumption would be I took this surface and just impregnated it back into the weld area, but that did not weld as smooth as I expected it to. Pool kind of jumped back and forth. We'll get into this section over here where we cleaned it with a 1/4 inch grinding wheel. Again, that was clean. And then this last section we'll get into is where we hit it with the flapper disc. As far as this coupon goes, I thought the one that welded the nicest as far as the pool and wetting it out and everything was the last one with the flapper disc. The weld pool did not wander around. It welded fairly quick. It's pretty clean. This surprised me. The first one surprised me. It's a colder weld, and that's another thing. I didn't cool this off each time. But as far as surface prep, if you clean your material, you're going to be making some good welds. So now we're going to get into something that's really kind of gross, manky. That's a good term, by the way. Pure rust, been out inside, wire wheel. I just kind of buffed over the POC and took the rust off. It's still there, I think. Grinding disc got down to it and cleaned down into the material, and then the flapper disc, it kind of cleaned over here on the edge, but it kind of floated over here on top. First thing I expect to happen is this is going to just kind of explode and maybe get some porosity. Some of this may flake off of there is what I expect to see. So let's give it a go. Gross. It kind of did what I expected to. It kind of blew up at first. I started adding filler wire and it settled it down a little bit as far as the weld pool not getting porosity. Your filler wire has deoxidizers in it that can help. But as far as the surface condition, it did explode a little bit when I started. It stinks, and it's got some crusty edges to it. All right, the next sample we're gonna go over is where we ran the wire wheel over the top of this. The bad surface condition is still there, or the POC, but we buffed the rust off, so let's see what happens with it. Again, much the same, kind of crusty edges, kind of weird looking. No porosity, and I think the reason we're not getting porosity is we're just kind of eating through the rust, and the manganese and silicone from the wires taking care of it. As I see it under the hood, it is not correct, so I wouldn't be doing this. I don't like welding over rust, mill scale, stuff like that with TIG welding. I like clean material because I know the weld's going to be going in there nicely. The next weld we need to make is On the part here that was done with the 1/4 inch disc, it is cut into clean metal. And that one welded very nicely. It was clean in the weld pool. I didn't have all this surface pond scum that's floating around. And on top of the weld pool, I could see the weld pool. The edges are a lot cleaner. So I know that that material was way cleaner than the rust or where we wire wheeled over the top of it. And then the last one is where we cut with the flapper disc. Again, it got into the leading edge the way it was laid on there, but as I came across, it just kind of sat up on top of this over here. Buffed the top of it off, and that was about it. And we're back to the weird reaction here of the stuff in the weld pool and on the edges. A little pond scum going on and some reaction. So by far, the one that welded the best on this particular part was the one that was cut with the disc right down to clean metal. While we're on this subject of using abrasives, I need to quickly mention, I've seen a lot of people using grinders and it's like, they're just moving them all over. They're real aggressive. They get them up in a steep angle and they're moving them all over real fast. I mean, you gotta settle down and let the grinder do the work, and it'll do by far faster cutting, leave your surface in a better state as far as being flat, grind marks and all that stuff. All right, so we need to move on to, since we're on DC, let's go ahead and do the DC part of the stainless. For beginning work on stainless, it is not critical. And when I say not critical, there's a number of methods that we can use. This is just plain old normal stainless as it came before we cut it up. It doesn't really have anything on it other than, doesn't have anything on it. It could have some light oils or something on it. To properly clean stainless, for non-critical applications, flapper wheel if you need to, wire wheel, but make sure that make sure your stainless wire wheel, don't put a carbon wire wheel on this. Also, don't put a flapper wheel that's been used on carbon or grinding wheel. If it's been used on carbon, don't bring it over to your stainless. Okay, in time, you can show some rust in and around your weld area because you have impregnated carbon back into your weld. It didn't precipitate out, so right at the toe, you're going to start getting some rust. Again, non-critical applications, it is not going to matter. We can weld on this without cleaning it, without doing anything, and we're going to show that. I doubt we'll see hardly any difference whatsoever between this surface condition, and I'm going to lightly hit this with a new flapper wheel just to shine it up a little bit. I doubt you're going to see any difference in what the weld does. Okay, so let's get to that. So we lightly hit this with the flapper disc. Again, nothing's coming off of it. So let's make some welds across the untreated portion of the stainless coupon and the part that we hit with the flapper. To me, that looked kind of normal. I didn't really see anything. I jumped forward here at the end, and but I didn't notice anything as far as the weld pool doing weird things. Edges look fine. And then we'll come down here on the sanded part, or the part that I hit with the flapper wheel, and we'll run a bead across it and compare. Pretty much the same thing. I'm not noticing any abnormalities in surface preparation. The untreated portion of the stainless welded really close to the same as the part that I hit with the flapper wheel. So that's the stainless part of it. Now we'll move on to the aluminum coupons. All right, let's move on to the aluminum coupons. Notice I pronounced that correctly that time. How do you clean aluminum And what's the problem with aluminum? Carbon steels, stainless steels, they kind of weld both the same. With aluminum, we've got a little bit of a problem, and it's called an oxide layer. Pure aluminum or aluminum alloys usually melt in and around 1200 degrees, depending on what they're alloyed with. However, the oxide layer melts at 3700 degrees. So it presents a problem on how to weld it. And that's why we use alternating current. So we alternate the current to help bombard or lift that surface oxide up off of there. Can we weld on a coupon that looks like that? And the answer is yes. That's not bad. Can we clean it and make it weld better? Quite possibly so. So the first thing we need to look at is, does this have anything on it? And it's got a little bit of black dust that comes off of there. And then the next thing is, how do we clean it and what do we use? Well, the first thing that I'm going to say is they make abrasives for aluminum, like the 1/4-inch disc. They are a special aluminum disc that has like these 1/4-inch bumps, these risers. If you just take a normal disc like this and you start grinding on aluminum, you're going to impregnate the soft aluminum into the abrasive wheel, and that's not cool. You're also doing something to the surface that you're just taking the garbage that's on the surface and you're just driving it right down into the material, and it's going to stay there. Same way with a wire wheel. You know, normally we use hand brushes and toothbrushes, and you think, well, why don't I, if I'm doing that, why don't I just grab this and put it on a grinder? This is so high speed that it's doing the same thing. It's turning at such an RPM that we're just taking this surface, lifting it, impregnating it right back down into this material. If you've welded aluminum and you're going along all nice and cool and everything, and you notice this black pepper looking crap floating in your weld pool, that's what I'm talking about. It's surface impurities and oxides. So there's chemical etch, there's machining, filing, hand wire brush. You get these little stainless toothbrushes at the weld supply store, and the correct way to clean aluminum, in my opinion, the best way is brush it, but brush it in one direction. Now, while I'm doing this, I'm noticing, and I want to show this to you, that's just hand wire brush with not much pressure. I'm looking at this black garbage coming off there. It looks like graphite. And that's the black stuff that you'll notice floating in your weld pool when you're doing aluminum. Non-critical work. It's okay to give it a quick brush and a quick wipe, and you're fine. Again, we can make welds on aluminum like this in its original condition here, and we can practice and make welds on it. The bead will be okay as far as our technique, but to properly clean aluminum, we need to get in here and brush this. Brush it in one direction, push or pull, but don't get into it and doing this, because then you're taking the black stuff and you're probably pushing it right back down into that surface condition again. So we have a nice collection going on over here. Some of that just fell on the table, the rest of it's on the paper towel. You can wipe these off with like acetone. A lot of people will wipe their aluminum down with acetone to really super clean things. Your filler wire. I haven't cleaned any of these filler wires that we've been welding beads with, but I can assure you this looks clean. It might not be. We have taken these and pulled them down a rag, and you'll see a fair amount of deposit or black. So, again, what looks clean, you got to remember aluminum sitting in the atmosphere, it has an affinity to pick up that oxygen molecule and create aluminum oxide. So, again, we're going to show welding on unclean material, with an unclean filler wire. I expect it to weld. It'll be okay. And then we're going to show welding on clean coupon with clean filler wire. I will probably see it more than you will on camera. I'll be able to see down in the weld pool better. And as you're welding and practicing at home, you'll probably see this as well. This first aluminum coupon is uncleaned, and I have unclean filler wire. I expect it to weld. I just expect I might see some black stuff floating in the pool is all. Let's see what we get. It welded okay. I saw a little black floaty. I was actually watching more of the edges and stuff around here. The weld pool seemed like it flowed okay. For technique, for practicing, it's fine. It really is. Now let's see what we get with a coupon that is clean with the hand wire brush. We wiped it down with the paper towel, and we wiped our filler wire down. You saw the black stuff that came off of it. We'll see if it welds any different. I think it'll weld pretty close to the same. I just expect it to be a little cleaner as far as the weld pool from what I'm seeing. Well, right off I noticed a better color. The color to me of the weld pool was a lot brighter and shinier from what I was looking at. I was dipping the wire in there. I didn't see any black stuff. It just seemed to flow better. So, you know, again, the aluminum oxide melts at a much higher temperature than the aluminum does. So by cleaning it, by wire brushing it, things were cleaner. It also seemed like I welded a little faster, slightly. For practice, you know, let's get back to TIG 101. This is all about you, getting you started, building your confidence. We get back to the viewer comments and concerns about how to prep material. And we demonstrated carbon steel, uncleaned, cleaned several methods. We got into a piece of the Mancub's old poop tube there, and it had some pretty bad rust on it and some pock, and several methods of cleaning there. Stainless, you know, I actually, you know, I'm looking at this. I actually think the unclean part welded better than cleaning it, except for my little juke move there at the end. Looks like I sneezed there toward the end of my bead. The unclean portion of the aluminum, yeah, it welded okay. And for practice, you'll be fine. It's practicing that technique. This one was the clean portion, the part that we took the time and cleaned with a hand wire brush. I thought it welded best as far as the aluminum part of it. Bead sunk in on the back side, both of them. Might have been a little hot there, but that's how I do sometimes. You know, again, appreciate the viewer comments. It's a great question. How do you do all this surface prep? And we could go into this a lot deeper, especially when we get into projects and detail work, edge and joint configuration. There's so many variables, but just to get you started, these are the basics. I surely hope that this helps, and if we can help in any way, please contact us, get a hold of us in the comments. We really appreciate your subscriptions to Weld.com over the years. Thanks so much for that. Check us out on Facebook and Instagram. What did I do? Action. Oh, that's your line. Shut up, Mike, we're doing a video.
I'm a bird.
What brought that on? Where'd you smoke lunch? Was that the proper level of enthusiasm?
No, I mean, that was, to me, that was reserved enthusiasm. I want some unbridled enthusiasm.
Well, I can get you some unbridled coming right up.